Prize for anyone who knows what the red region is in the brain there. No neuroscientists in the house? That's the coordinate nucleus. That's the learned response function. Anyway, by the by. For me, I spent a lot of time talking about Quid, but I'm not going to talk too much about Quid today. I'm going to talk instead about a little bit more things that are on the edge of my mind. And really, the edge of my mind is thinking about the human mind and also how that interfaces with algorithms. And particularly about the limitations of the human mind. It's one of the things we like to think almost that the human mind is capable of anything. It can sort of do these amazing feats. But the reality is it's some sort of combination of software and hardware that does have limitations. And one kind of fundamental limitation that it does have is the speed of thought. The speed of thought happens in a way that can actually be measured. And a bunch of scientists got together to actually sit down and try and measure this. Now, they stuck chess players into an fMRI machine. They shone up above their heads a chessboard and said, is the king in danger? Is the king in check? And they measured the response time, and they looked at the response within the brain, see what areas lit up, and they also saw how long it took. Now, for an amateur chess player, it's about 900 milliseconds for the brain to register whether or not the king is in danger. For an expert chess player, it does increase. It does get faster. But it tops out at 650 milliseconds, 0.65 of a second. Now, this kind of small limit of the human cognition has tremendous implications in the financial markets. And of course, this is a graph showing that. What it means, indeed, is that where the human mind finishes, the algorithms take up the slack. They come into the world of high-frequency trading and start to dominate global markets. US equities market of all completed trades is now somewhere north of 60% done by high-frequency algorithms. And if you look at just the total number of trades that are out there, it's even higher again. So this world kind of comes about because the brain has a limitation. And for me, that's really, really fascinating place to look at and think of what are the limitations of the brain and what does that mean for the algorithms that will take up the slack. This also, forces us to change our context of what a financial market is. We have to think now of servers being co-located on top of each other to be close enough to the output of the data source coming through because the speed of light is a factor in the equation of any model that they're going to make. We need to think of these rooms of servers co-located, and we need to think of ships now laying new fiber optic cables between New York and London to shave 5 milliseconds of round-trip time at the cost of $300 million, all because we can't think fast enough. And it's had, I guess, and depending on who you want to believe, this is the Bank of England, some benefits. The increased speed leads to increased sense of liquidity. The bid-ask spread going down to almost zero almost all the time. We know that doesn't always happen because sometimes this happens. And for those that don't read trading screens for a living, that's probably more familiar for you. Sometimes the algorithms get together and decide collectively to wipe about $1 trillion in market capitalization off the global financial markets, only to return it about 15 minutes later with nothing really happening in the world around that. So the algorithms that we've put in place of humans, although quicker, sometimes misbehave because they're not that smart. And they're not that smart because they've got to be quick. So I like to think of it like this. You can kind of think of the human decision ecosystem, kind of time of processing information on one side. So you can think of like 3 hours to read a scientific journal, maybe 2 hours if you're on a Newton. New York Story would maybe be 30 minutes of reading down towards a 140-character tweet or a news headline at 3 seconds. But as we know, beyond that sort of 1,000 millisecond mark, there's not enough speed in the human brain to take the information in, to cognitively process it, and to make any actions. And so this is the algorithmic ecosystem that takes over. This is an ecosystem governed by the speed of light, where we're looking at 65 milliseconds for light to travel backwards and forwards from New York to London. We're looking at microseconds for the fastest NASDAQ trade time that you can make. And then you're down into kind of 740 nanoseconds, where you can get hardware-accelerated chips to make trades for you. Now, a nanosecond, unless you're physicists, there's probably more physicists than neuroscientists, a nanosecond is the amount of time it takes for light to travel 11.8 inches. And that's why you have to be close to the output of the Ethernet cable. So this is what that world looks like. We can't see it, but we can kind of see it post hoc. You can kind of zoom in and you can see in the amount of time it takes for an amateur chess player to realize the king is in danger. All of this has happened. And sometimes these algorithms do all of this while we're not quite aware what they're doing. The case in point of Knight Capital, a couple of years ago, they released an algorithm onto the market. It was never supposed to be on the market. It was an algorithm that was meant for testing. It somehow makes its way off the staging machine and into the real world. Competition ensues, and it's buying high and selling low. And it does that for 45 minutes and loses Knight Capital $440 million. Knight Capital knew something was wrong. They just didn't know that it was their algorithm that was causing the mistakes. And so these algorithms, they exist in this kind of funny world that's beyond our comprehension. And they must exist because we can't think fast enough. And it has pretty profound implications. Now, algorithms, such as the one there at Knight, are really just reading zeros and ones. Sort of, by efficacy of speed, they're just sort of processing zeros and ones. So what happens when news comes out? What do they tend to do? Well, we've got that happens a lot. They have scheduled news releases from the Fed. Here's one of them. This is the E-mini future volume being traded. This is when the scheduled news is going to come out. And what you can see happen over here is that the algorithms all decide to leave the market. They're all pre-programmed to get out of the market when a Fed report comes out about the unemployment rates because they don't know how to read it. And if it was bad, they might be trading in an area that they weren't trained for. So they leave the market. And of course, what's really disturbing about this is the size of the market that you're left with when it's only humans trading on top of it. It's their world. But, of course, if we know that the algorithmic game is competing at the speed of light, that's an eternity, those 6 minutes, while no one's in the market. It's a huge opportunity. And so, of course, algorithms are learning to read. And so this little world of sort of stopping off there starts to move up here. And they start to process this text. They start to read headlines. They start to read tweets. And they start to read even Washington Post articles. And they do that because it opens up an amazing advantage. And so they can read through a thing about a bomb report going off in Baghdad and maybe make oil future trades on top of that before you as a human have even had time to download it onto your latest iPad. And that's all well and good, except when this happens and a fake news report from AP Newswire comes out, says there's a bomb in the White House, and then this happens, the algorithms leave the market because they go, I don't really know what's going on here. I know something to do with a bomb happened, and probably I'm not trained for this, and $200 billion is wiped. Humans come back and set it straight, and the market is a lot more volatile as a result. One faked, hacked tweet. Now, of course, if algorithms can start to read the news, surely they'll start writing the news. They start writing the news. Now, again, how much of the news is going to be written by humans and how much of it is going to be written by algorithms? So that brings us to the world of algorithms moving into our world, into our space. And so when you open up New York Times on your iPhone, it takes about 800 milliseconds to load that. You don't really notice that because you're a human. But 150 milliseconds of that is made up with an online ad auction, where they take your personal vector of where you've been, where you are, who your friends are, what you like or don't like, and then they compete against your presence, your attention. And there's an online ad exchange, much like we would bid against E-mini futures, but this time it's for you. 61% of the internet traffic is now non-human. It looks something like this. And it's increasing. Last year it was at 51%. Pretty soon this internet is going to be for algorithms. It already is there. We just don't quite know that yet. So a lot of people at this point, you want to push the button and say, stop. You know, you've got algorithms trading global financial markets and crashing $1 trillion of capital to be returned, maybe, maybe not. You're trading my personal information to bid for my presence, to kind of direct me in a way that may be beneficial to buy something. But the truth is actually we can't stop it. And we can't stop it because the human brain actually needs algorithms. It needs assistance. If we're going to survive in this world with the complexity that's around it, we need help. The question, though, is where is that help coming from? And what are the motivations and the motives by which the algorithms optimize themselves? Here's a couple of the major ones that we use to filter information. Google, PageRank, of course, they've taken it much beyond the kind of the simplistic graph analysis of this. And Facebook EdgeRank, again, there's many, many features, but you can think of these as being two kind of major algorithms that we use to interact with information. And they serve the job of kind of filtering it for us. You can think of the mathematics, but you can also think of the economics. One of the major economic functions of these algorithms is the electricity it takes to power them. The huge amount of electricity that runs the multitude of data centers that run around the world, storing our information, running our algorithms on top of it, and serving us up our latest friend update on Facebook. Kind of back of the envelope stuff, you can kind of see what it costs and the revenue per user for each of these spaces. Google makes about $30 a year per user. Facebook is doing a little bit worse. They're at $6 per user. And it's interesting, though, on the other side of that is the cost per user. This is really fascinating. It costs about $1.20 to run a user on Facebook for a year. That'll vary a little bit depending on which country you're in the world. It costs $12, $13 for a user on Google. Now step back a little bit and think what that means. It means that you are giving Facebook all of your information and saying, filter it for me, choose my friends, choose what I see about them, increasingly choose the news I read about them, and do it all for $1.20. I wouldn't buy $1.20 coffee. But we run our lives through these things. And we should really think about these algorithms as kind of being like the fast food algorithms for information. You get a lot of it, they'll give it to you, but maybe the algorithms aren't really acting in your best interest, perhaps. Why? Because these algorithms are fundamentally driven by advertising. When algorithms optimize for advertising, they may be not optimizing for you. By way of, there's an interesting stat reading around. Google actually returns Wikipedia 85% of the time with the most common searches on the first page. We can start to write algorithms to actually update my Facebook status for me so I don't need to. This is Facebook bot. I don't know what it is. Came up with that one. But it forces us to think about if algorithms are going to shape our lives and shape our information and shape our friends and shape our communities as they've shaped the financial markets, how might we reimagine what they might look like? Well, two really kind of fundamental yet two very simple vectors. History. Does the algorithm remember all history or does it forget everything as soon as it happens? And identity. Do I have to be me or could I be an avatar? And up and to the right, all history, pretty much, and mostly me, Facebook. Up here, all history, but I can be an avatar, that's Reddit. You've got karma, so that kind of keeps your score as you go through. Down here you've got 4chan. Some 4chan, some betards in the house. Don't go there. But that gets rid of history and identity. And then, of course, down the right-hand corner, you've got identity and no history, and Snapchat. Now, one of the things that should jump out of you is the kind of the difference between what happens and what the world looks like when you're interacting on Facebook and what the world looks like when you're interacting on 4chan. And that is just by varying these two parameters. You end up with entirely different worlds. And again, it shows you the power that the algorithm has over our experience. And again, it forces you back to say, well, who are they optimizing for? Because identity and history is most definitely the most profitable, but it may not be the best for us as a community. So to kind of think about this as the kind of the world that we're in right now, the advertising-led interaction with algorithms. Kind of how do we interact with algorithms? And I think the predominant way that we do it is through advertising today. And the relationship is kind of one of we're the product. And the cost for us is free. But there are other ways. I think we're going to see subscriptions. I think we're going to see people coming out and saying, you know what, I want a little more control of this algorithm, the information that it gives me, the friends that it chooses. I want it to nudge me in different ways than it's currently doing. Instead of going to be the kind of the product, I'm going to be the owner. And I might actually pay some money, $100 a year, to actually interact with information in a way that was more optimized towards me. And then the other two are kind of at the edge of this. This one here, the techno surf. The relationship of that human with the algorithm is very much one of servant. And the cost, actually you get paid, but it's about 1 to 2 cents a task. This happens a lot in Mechanical Turk. This happens a lot when people are being paid to do jobs that algorithms aren't able to actually do, like reCAPTCHAs, like signing up for Hotmail accounts, like creating Twitter spam bots. And this is the kind of the world where you're actually a servant of the algorithm, being employed by the algorithm to do things that it can't actually do without your help. And then on the other side, you've got a world of augmented intelligence. This is where instead of having the algorithm give you an answer, you're much more in a relationship with the algorithm where you're kind of working backwards and forwards, and effectively you're driving it. And that's quite an expensive place to play. And there, you're sort of talking upwards of $1,000 a year to play in that space. Now, leaving kind of a final thought, we talked a little bit about the algorithms reading the news. This is algorithms now writing the news. And this is a set of tweets coming out, Mexican Twitter bots alleging that a reporter was not killed by the drug cartel. Algorithms writing news to influence public opinion. And we can actually go through and analyze that stuff. And you can see there the bots in red and the humans in blue. And you can see the kind of the volume now that the bots have. And that's not a very smart bot because we've plotted it through time, and you can actually see that the bots that are there, they're kind of spiking. And so you kind of know that maybe you could kind of create spam engines against that. Well, version 2.0, and this is now happening in China on Tiananmen Square protests, now you're seeing one that's a lot harder to discern, a lot harder to kind of understand and pull apart. And let's sort of leave on that. The KGB's just put money into this. IARPA and DARPA have got money going into this stuff. Algorithms are going to be more and more a part of our lives. They're going to be more and more a part of the internet. They're going to shape and change how you see yourself and how you see your friends and how you see the world. And one of the big questions you're going to have to ask yourself is, what's my relationship with the algorithm and what do I want it to be? And with that, I'll go back to Matt. Thanks.
Thank you. Now I feel better about why people never respond to my friend requests. They're all bots. So that was a fantastic talk. Thank you so much. And one thing I particularly appreciated is that you didn't talk about what you do, actually. So I thought it would maybe give you a minute to talk about Quid and what you're building there, which is pretty fascinating as well.
We build augmented intelligence platform. And so there's a few companies that are building in that sort of space. I guess you could kind of think of the likes of Palantir, Recorded Future, ARSD, and Quid, sort of this first wave of platforms designed to let you interact with data in a way that is sort of both exploratory but also kind of immersive. You don't quite know necessarily what the data is going to tell you, but you're using it to try and answer some very difficult questions. Questions that humans alone couldn't answer by themselves, but ones you wouldn't really push a button to answer either. And that may be, what is, what are the latest research that Google's working on, and how does that, impact the acquisition that they just made? Or it might be like, how is the situation in Crimea unfolding, and how is the language that's being broadcast in Russia differ from what that's being broadcast in Bulgaria? And maybe I can kind of piece them together to think about if there's any kind of transrelational ties that might be emerging that I hadn't seen before. So it's quite deep questions, but ones that I think you want to have a range of quite high-powered algorithms at your disposal to answer. You don't want to do that without it.
Great. Actually, I have more questions on that, but are there questions? Yeah, I mean that's the type of talk that doesn't where people are just. Yeah, exactly. So I'm actually let's keep on talking about Quid for a second. And so, how does it work? What kind of information does it ingest? What does it do with it? What's the product that comes out?
So it's a web platform where a lot of data comes preloaded. So the streams of information that are out there, everything from Twitter through to kind of foreign language Japanese television transcripts, through to Stack Overflow, questions about Elasticsearch, through to huge amounts of information there. You can also bring your own information in. So it might be CRM reports from your sales team, or it might be your internal documents that you're keeping. Once that's there, you're applying a range of algorithms on top of that, everything from entity recognition through to sentiment, but also most importantly, I think, is looking at being able to connect the different data pieces together. So what that does ultimately is it takes a complex set of relationships and then projects them down into an interactive 2D, 3D environment where you can kind of navigate that data to see the structure that emerges. So that structure might look something like, the different clusters of patents that Google's filed, or the different clusters of conversation on Japanese television about the nuclear restart. Things that, if you were kind of an expert in the space, you might know, but by plugging into the system and leveraging the algorithms, you get a lot of that encoding kind of for free, and then you can go and figure out what it means or what you want to do with it.
I do have one question over there.
Hi, Jedi from Geeklist. So with, I guess with the data you're collecting about bots and, kind of like automating their posts on Twitter, et cetera, particularly with like propaganda and government, it seems to me like you might be able to anticipate government actions based upon the propaganda that they're spewing out, maybe a day ahead of time. Have you done that before?
So for us, it's very much about giving the tools to the people that are creating and shaping the messages. So we work a lot of PR and marketing, drive Quid to kind of shape the stories, and they try and not so much predict what the message is going to be, but be actually the ones that are making it. And that, of course, has the government clients doing that stuff as well. So, people are using this not to kind of predict, but to shape. And I think that's one really important thing is once you're in kind of a driving seat of power, you don't really need to predict the world as much as you want to think about what world you want.
Great, thank you. So that's all the time we have. That was terrific. Thanks.